Hello class, this is what my final spreadsheet looks like, and I'm going to go through it. I'm also going to describe what it is that I want from you to give you credit for this assignment. But first I'm going to go through the explanation of this completed spreadsheet. Just to review, each of these green bars, or cells rather, stands for a element in the calculation of the values that you see here, which are the amount that we expect to make or lose in the first 6 years. And I've just chosen 6 years so that it matches the calculations that they have in the book as far as the answers go, and how we end up with this number here. You could carry this out for 7 or 8 or 9, but we're going to do it only for 6 years. So just to look at this calculation, for instance, if I go to define assumption, first I have to reset my simulation, so let me do that. Oh, okay. So here I see we have a uniform distribution, not the curve, the normal bell-shaped curve of the normal distribution. It means that every value between $10 and $15 is equally likely. Maximum 10, minimum 10, maximum 15. As another example, I'll look at the calculation or the define assumption here. And here I see that the distribution is normal in that we have, here's the mean value and the standard deviation. So this is the, this field is, let's slide this over here. Just to remind you what this field is, this is the how much of the market share the company thinks they're going to get, 30% plus or minus 3%. The areas in blue are defined forecast. And here we simply use a formula, which I went over the first time we had a video on this, I believe. It'll be easier to see if I don't do that. Let me increase this just a bit. This formula is simply a way of calculating the expected value in the first year. This formula is the expected value the second year, and I do that for 6 years. You can click on any of these and see the formula that was used to produce the calculation or the number that you see in these columns here. The last part of this is something which I'm not requiring you to know, because this chapter really didn't go over it, but it's a formula for net present value. And if we look at net present value, the formula for it, we see it's actually an Excel function, and it takes value L3, which I have here is 10%, which we call discount rate, and then F3, G3, H3, I3, J3, K3, which are just these three, all these numbers here. You notice that if I just simply add them up together, if I go down to this area here, you see that, actually I'm not sure you can see that, but this, these numbers all added together equals 1,890,000. But our net present value is only 1,221,000. And that's because the formula net present value uses a mathematical statistical formula to take the a series of values, namely how much you might make each year for 6 years, and then applies in the industry it's either called a discount rate or a hurdle rate or expected rate of return. And in this case, we're expecting that we're going to want to make 10% in our investment each year. So this number here is actually a result of this formula for something called net present value, which is described earlier on in chapter 1 on pages 12 through 16. If you're interested at all in the financial calculations of how projects are going to be successful or not, you can take a look at those pages. So I'm going to run the simulation here, and notice I've got 1, 2, 3, 4, 5, 6, 7 forecasts. That's 7 blue cells. Each one of these has a formula, and each one is going to be run 1,000 times. I'm going to hit start, and you notice how I get a whole series of graphs. Here's the graph for cell G3. I'll move that down. Here's a graph for H3, cell H3. You notice these values, 322, 905, 365, 851, these were the values that were in the cells of, that we've labeled here, G3, H3, and so forth, which I can show you by dragging these down. If we look at, just to show you, here's a forecast for I3, 414, 509, and if we look here, I3, 414, 509. So this graph here corresponds to this cell here, and it shows that the highest value, or the most likely value is at 414, 509, but there's probabilities on either side that the number could be less or more. So when you take all of this into consideration, I'm going to now just close all these forecasts except for the one for net present value. And that was in cell M3, so let's find it. Here we go. Here, actually, I'm going to go back to the chart. Before I do that, let me close. Now I've got M3 all by itself. This is M3 here, cell M3. Actually, let me close this too. Okay, go back to the chart. I click there. I see my distribution. My most likely value is 1221360. That's 1,221,360, and that's of course the number I get here. But when I look at the statistics, I see that the mean value is 1,204,000, which is less than the 1,221,000. This is the mean, which is another way of saying the average, and it's lower. That means that if you let's go back to the graph. If you took the average of all of these, you wouldn't come up with 1,221,000. You'd come up with that 1,204,000. Go back to the statistics. Here's the base case, but here's the because we applied crystal ball, we actually come up with a number that's slightly lower. So, having said all this, this is a little bit beyond what I had intended for us to be responsible for learning, because this is a little bit beyond, I think, what this chapter was implying that you had to know. Therefore, here's this I'm showing you is the final example, or the actually the answer to the first question, which is what is the expected value of the project, and that's this number. This is for over, and we've made the assumption that we're only going to go out 6 years out. So this is the expected value of the project over 6 years, but this is the mean. So question one, this is the answer. If you don't get this answer, don't know how to get it, that's fine for now. I'm not requiring it. I'm really more interested in this part of the problem, defining the assumptions and then defining the forecasts. But anyway, the question in the second question in the book says run the simulation 1,000 times. Well, that's what we just did. And when it says plot a histogram, it's not asking you to do it by hand. It's asking you to use Excel to plot those graphs. And you saw that each of the graphs appear for each of the cells, F3, G3, and so on and so forth. The last part of the last question, question 3, says, is there a difference? Let's see, the exact question says, how does the average of the simulation compare to the expected value? Well, the average, or the mean, was 1,204,000. The base case, or the expected value from this column here, was higher. And the answer there is simply that when you have large numbers like this, there's just a built-in level of uncertainty. And Crystal Ball is designed to expose or let you know just what the uncertainty is. So even though the simple, I call it simple, of course it's not simple to many, but this formula here gives you a number like this, but if you apply Crystal Ball, which is why these cells are blue, because I've defined a forecast and then run the simulation 1,000 times. When I do that, I get a number which is more reflective of the uncertainties that I built into these assumptions here with the standard deviations and so forth. So that is the ultimate solution to this problem, but let me just reiterate that for you to get credit on this, all I simply need from you is a spreadsheet which shows these assumptions defined in the way that I've described them, and these forecasts up here as I've described them. Simply put, if you look at these formulas here, and I'll send this out so that you have these formulas in doc sharing. If you look at these formulas here, and then you go to define assumption, let's click there. Let's reset the simulation. Okay, watch what I'm going to do here. Let me cancel this for a second. I'm going to copy this formula. I'm going to hit Control C, and that copies it. And now I'm going to go here, and I'm going to click Define Forecast. Here I'm going to replace it with this formula. I'm going to hit Control V, and that paste is there. I'm going to hit OK. You notice I still get the same formula. I still get the same number. That's because this formula is what's calculating this number. So if I go back to Define Forecast, I see this number here, but it's really because it's the formula here that's creating this number here and is showing me this number here in my forecast. So, of course, I know that this is more difficult for some, less difficult for some of you, but the main goal is to understand basically how Crystal Ball applies its statistical methods over numbers which have some variation, and then gives you a good average estimate of what the values are going to be. And if you have Crystal Ball installed yet, if you don't have Crystal Ball installed yet, then you know I'll be working toward that goal with you. If you do, then you should be able to play around with this spreadsheet, which I'm going to send, and see how you're doing it. So thanks for your efforts. I know this was a difficult one, but we'll be moving on.